to our second presenter for today, Adriana.
So welcome everyone. Thank you so much for being here today. It was a wonderful presentation, Jillian, and I'm really excited to see the rest of the presentations for the day. I'm Adriana Diaz Lozano Patino, and this summer I had the pleasure of working with the Water and Energy Research Lab at U of T and trying to help them understand the factors that impact water and sanitation access in peri-urban communities in Mexico. Oh, I apparently don't have control of my own slides. Interesting. Sorry about that. Okay, there we go. Can you see my screen? Hello?
No, I cannot see it, but maybe slides problem?
How about now?
Now we can see it.
Okay, lovely. Sorry for that small technical challenge. But anyway, as I was saying, Mexico, like many developing countries, is facing the aftermath of a rapid and disorganized urban expansion in regions that we know refer to as peri-urban interfaces. These regions lie in the outskirts of cities and present a mixed urban and rural characteristics. And it is exactly this fragmented development that is so intrinsic to these regions that lead the communities living in them to face challenges of lacking infrastructure and inefficient access to basic services, such as water and sanitation. And to put the problem a little bit more into a bigger perspective, let's talk about the water crisis that Mexico faces. 77% of the population lives where only 31% of the natural water resources can be found. And to exemplify this, in the Valley of Mexico, which is a central part of the country where the bigger metropolitan cities lie, the water stress levels are well beyond 100%, and this is a situation that is not expected to get any better in the coming years. And it is this lack of provision of water that leads to a second big challenge, which is sanitation. Around 11 million Mexicans lack access to safe sanitation systems, and over 38% of Mexican houses do not have improved sanitation facilities where the waste is properly managed. And it is this particular problem that not only motivated me to kind of understanding a little bit better, but also motivated a PhD student as well, Pablo. He, along with the NGO Techo, visited many peri-urban communities in Mexico last summer to kind of gauge a little bit better what this problem really entails and understand their context. And what they found is quite impacting. For one, most of these houses do not have access to pipe water networks, and they have to resort to other water sources such as water truck delivery systems that are not supervised. And what's more, there is a very varied diversity of not really properly sound structures that conforms the households of this people. And it is a combination of these factors that leads to ineffective sanitation technologies. What we can appreciate here are examples of sanitation systems within this peri-urban households that clearly have a poor management of wastewater, where fecal matter has been stagnant in the toilet bowls for many hours or even days. So I wanted to understand what exactly is leading these households to have this problem. And to dig a little bit more into the context of it, here we can look at the types of sanitation systems that these communities have. And something that stands out is the fact that across all these peri-urban communities, the number of houses that have access to cistern flush toilets connected to sewage, and by this I mean toilet systems that are connected to the main water network, is very, very low. And particularly, the communities in the outskirts of Mexico City, such as Xalostoc and Jardines de San Juan, did not have any households that had this type of sanitation system. So how does this affect their life? And more importantly, what affects access to safe sanitation? What are the common characteristics that all of these communities show to be able, to enable this people to not have an effective sanitation system? So what I did to be able to understand this challenge was first obtaining data from various Mexican databases and interviews performed by local NGOs. Later on, I had to curate these databases due to many discrepancies that exist between the data points. And with this in mind, I could actually define what a target variable would be, aka what a safe sanitation system was within this context. And with this, I could identify what the key parameters are in order to find whether a particular house is going to have access or not have access to this system. And all of this would eventually inform a design framework upon which sustainable sanitation technologies could be evaluated. So, to explain a little bit more of how I was able to do this, I perform a univariate logistic regression on all the community descriptors that I obtained from the Techo interviews. And these descriptors talked about various parameters such as the demographics of this population, the structure of their houses, their economic conditions, and I defined what I wanted a safe sanitation system to look like. In this case, a cistern flush toilet connected to sewerage, as we can see in the diagram. Now, I must mention that a sanitation system connected to the main water pipeline and drainage is not the only type of safe sanitation system out there. Remote and off-grid technology such as a septic tank with hydraulic discharge or dry toilets can totally be safe. However, given the conditions of these communities, maintainability is not really a factor that comes into play, and thus leads both of those off-grid technologies to be very ineffective. And what I wanted to get out of this model was to understand what were the most relevant parameters that affected whether or not a house was going to have a sanitation system connected to the main water pipeline, and what particular relationship these parameters had. And a challenge that I faced as I was trying to go through my data set is that it is kind of hard to compare parameters such as the square footage of a house to whether or not its population is affiliated with a health insurance plan. So what I did to be able to draw this significant comparisons across different categories was standardize my parameters via weighted evidence mechanism. And once I had that, I was able to select the most statistically relevant parameters, and later on actually throw everything into a logistic regression model. And what I found was that, as a matter of fact, the factors that influence the most whether a particular house is going to have access to sanitation or not is going to be, for one, the main water source this household has. Whether they're connected to the centralized system or not is going to impact how frequently they're going to be able to have water access. Secondly, the structure of their dwellings. There is a tendency for those houses that had less structurally sound infrastructures to have a lower tendency of possessing safe sanitation systems. Of course, the location of the communities. Some of these communities in the periphery of cities are actually located in mountain ranges that really complicate building infrastructure that could access and connect them to the central drainage network. Furthermore, the legal status upon which these households are built. Like I mentioned before, a great population of the peri-urban environments are actually set upon irregular settlements. This means that the government is not regulating this land and thus is not realistically incentivized to provide infrastructure. What is more, affiliation to a health program. Now, this last parameter might sound a little bit abstract right now, but what this represents is the portion of the population that is part of the formal economy in Mexico. And being part of the formal economy also implies having a more stable income of the overall household. Clearly, noticing and identifying these parameters is not where the work ends. There's still a lot to be done, and especially a lot to be done to be able to develop a proper design framework. So for one, we need to expand community engagement. Clearly, due to the pandemic and travel restrictions, we were not able to go to these communities and interact with them more, but it is crucial to expand the data set we have and to understand their water needs from their perspective. And furthermore, obtain quantitative data of these relationships between users and sanitation technologies, so that we can later on include updated national databases information that we can throw into a multivariable logistic analysis where we will not only see the relationship of these individual parameters to the target variable, aka a safe sanitation system, but also how they relate to each other. And ultimately, this will all be incorporated into a design framework that will analyze and evaluate whether a sanitation system would be effective in the context of a particular community. Sometimes as engineers, we fall into the nuances of the technicalities of a design, and we often forget the social and cultural context that we're developing a technology for. And it's very important for us to take that into consideration if we want a particular system to be effective in the long run. Thank you so much, and I would like to thank World, Techo, and the University of Toronto for allowing me to proceed with this research project. And yeah, thank you so much to UNERD and everyone here present. Thanks.
Thank you, Adriana, for your presentation. Now I would like to address the judges and ask if you have any questions.
I'll ask a question. This is Glenn Hibbert. It's a nice presentation. You've outlined what's, obviously really a complicated problem. There's a lot of things. It's a really difficult sort of thing. So maybe tell me if you had to sort of boil it down to what do you think would be if you could do one concrete action here to sort of help the situation, what would you put down as what's a good concrete action?
Great, thank you. That is a really good question. So a concrete action, and is something that is actually being developed, and that one of the grad students at Worley is working at, is the Techo NGO. What it does is go to these communities and kind of analyzes the current infrastructure these households have. And as such, they try to see if they could implement an off-grid sanitation system. And what I mean with this is developing pit latrines or septic tanks that are actually going to require really low maintenance. So what this would allow is for these houses that don't have a continuous supply of water, that would not allow for the wastewater to be discharged, to be properly separated from the humans that are using the sanitation systems. So a more specific action is serving these communities and just analyzing whether the geographical conditions are going to allow the buildup of this systems. Since that, for example, septic tank, what we need a decent amount of the surface and the soil underneath the houses needs to be needs to allow for this type of system to exist. So it's kind of analyzing what communities it's better to connect them to the central water system and to the central drainage, and which ones would be better off with an off-grid technology.
Okay, so it's about figuring out exactly where the best solution is needed, and then figuring out how to apply it. Yeah, okay, that's good. Yeah, thank you.
Thank you.
So since we still have one more minute, I would like to turn to the attendees. Do you guys have any questions to the presenter? If not, thank you, Adriana.